How did you do? Did you get stuck on number 49? It's not an easy one. So you know what I would do? I would put a big ass corazon, okay? I would be like, ooh, this one's tricky dicky, you know? Yeah, it's a little bit tricky dicky, but maybe you did a different approach than I did, but this is what I did, okay? Go through this right now and ask me questions about it if there's something that you don't understand. But the most important thing to do is keep your eye on the keep your eye on the prize. Are you approaching this guy as you're working on this, okay? So look what I did. I think the trickiest part is also 3x. I wrote it as 2x plus x, but then I went even further to write x plus x and then x. And then that's already u, but I know that I have to apply the cosine sum rule here again. And that's the thing. I think you have to be careful with your arithmetic and your signs, S-I-G-N's, like your minuses, okay? Don't cut any corners, okay? Make sure you show all the work, okay? All right, if you don't understand, ask me, okay? All right, let's try this one. This is continuing with part 3, proving identity, but it's a little bit trickier and dickier at first. You'll see that this one's actually easier than the one before, if you notice something, okay? I can tell that I would like to expand this. Use the left-hand side. Get this. And you're probably thinking, but Miss Chang, you've been doing that every time. LHS, and then you solve it for RHS. But sometimes you might have to go the other way. So I'm just always clarifying why I chose this one. I know that it's gonna be easier for me to make 5u and 3u become something like this than making this guy, condensing it to that. I don't know. For me, it's like that. But I don't know. Maybe for you, it's a little bit different. I don't know. You could try different techniques. I don't care. Okay? All right, if you want to stop the video and just look at the answers, go for it. But I'm going to choose the left-hand side. Okay, I'm going to use the left-hand side. I'm going to go tangent 5u and tangent 3u, right? Isn't that really, let's try to write. And remember, we're keeping our eye on the prize. What I notice on my right-hand side is I see 4's and just 1 u's. Now, what's the characteristic of a 4 and a 1? 4 and a 1, if I add them, becomes 5. Whoa! 4 and 1, if I subtract them, I get 3. Whoa! So hopefully you're thinking, wait, I think I might make 4u and 1u. I'm going to utilize that. So let's see what I mean by that. But you're right. Again, I told you, for any of these problems, you have to be nimble. You got to know, how can I manipulate this so it makes sense to what my goal is, what my goal is. So I'm going to write this guy as tan u, 4u, 1u, times tan u, 4u, minus u. Now, I think it's pretty clear what you have to do. Apply the sum and difference rule of tangent here and here. Okay, if you want to stop the video and surprise yourself, you can do that, okay? So I'm going to do that here. Okay, I'm going to try, remember, I'm keeping my goal on the prize. So I'm going to apply the tangent sum rule. So I know tangent sum rule, I add each of the u and the v, because this is my u, this is my v, this is my u, and this is my v. Okay, now I get over 1. Now I know that that's minus, because the denominator is going to be minus. Tan 4u, tan 1u. Now times tan 4u minus tan u. I'm just applying the formula, okay? And 1 plus tan 4u, tan u. And when I multiply this together, what do I get? Dun, 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 dun. I basically get these squared, right? You can separate these. You can do the numerators multiply and denominators multiply. And it just becomes like a plus b times a minus b. So here's what I get. I end up with tan square 4u minus tan square u. Because if I FOIL it, okay? If I distribute tan 4u plus tan u to all the tan 4u minus tan u, then I end up with a square minus b square. And I get the same thing here. 1 square minus tan squared 4u. Tan square u. If you don't understand this, it's a little bit of the algebra issue, so let me know, which is the right-hand side, and we could go over it more in detail together, okay? All right. Let's go on to the last part. You made it, amigos. Dun, 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 dun. Next part's super duper easy now that you're a pro. Part 4. Where's part 4? There it is. Okay. Now, this is a worksheet here that I've included because I think you can now do this after you did part 5.2 and 5.4. Okay. 5.3 and 5.2. Let's do this. Prove the reduction formula. What the factor does reduction mean? Reduction means to make it reduce, right? To reduce, okay? Also, this is also proving, so you can use the left-hand side or the right-hand side, whatever you choose. But we're reducing, so it's better to choose the more longer side and then try to reduce it. This is actually easier, and I'm thinking that you're like, oh, looks pretty simple. All right, and there's also a relationship between cotangent and tangent, right? So you can use that fact as well. Okay, I don't know what to do, but I'm gonna go, okay, LHS, okay? And I'm gonna go, well, I don't like to use cotangent because right now my other side is using tangent. So you know what I'm gonna do? I'm gonna actually go like this. I'm gonna write this as cosine of pi over 2 minus u over sine of pi over 2 minus u. But I know using cofunctions that this is actually sine u cosine u. Ding, 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 ding. Sine over cosine is tangent u, which is the right-hand side. Wow. Now, if you took a different approach and, did it differently, but you ended up with the same thing, that's all good, okay? Remember that you got to be nimble, okay? You got to know exactly what to do, which technique to use whenever you get these kind of problems. Number 42. Dun, 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 dun. Ask me questions. Cosine of x plus pi over 2 equals negative sine x. Well, right now, it does not look like it at all, okay? So what are you going to do? What are you going to do? I like these problems because they're utilizing your identities from 5.1, 5.2, 5.1, and 5.3, okay? Right, we're reducing, so of course we're going to be using this guy to get to here because I want to get condense it, right? Reduce it, okay? So I'm going to go LHS. So I don't know, I'm just going to try something. I don't know what I'm doing, but I'm just going to go, you know what? I'm going to use the cosine sum formula. So I'm going to go cosine of x, cosine of pi over 2. I know that the cosine is inconsistent, so I know it's going to be minus sine x, sine pi over 2. I'm going to simplify everything that I can. Cosine x, I can't do anything. Cosine of pi over 2 is 0, right? Isn't it 0? Okay, minus sine of x, sine of pi over 2 is 1. Therefore, this becomes 0, goes away, hiya, goes to 0, right? The other guy becomes dun, 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 negative sine x, which is in fact the right-hand side. Okay, we've done all these examples. I think it should be enough for you to try everything now. I know it's a lot to take in. Take it slow. Ask me questions. Come in for help. I'm here for you. Peace out.